So when I am solving by elimination, the first one kind of already set up nicely in order for me. X, Y, number. So we're going to keep that one. The second one, I would like the X to be first, the Y to be second, and the number to be third. Now with elimination, remember this is that multiplication thing where we try to either cancel out the X's or the Y's. Which one do we want to cancel out here? X's, sure. What is the common multiple for 3 and 2? 6. I will multiply the first equation by 2. That gives me 6x minus 8y equals 26. When I do elimination, I will always make the second one be the negative number. So when I say that the common multiple is 6, I'm going to multiply the second one by negative 3. I always like to add rather than subtract, just because if you subtract, sometimes you will get things wrong. It's not always good. So if I multiply the second one by negative 3, it gives me negative 6x, negative 9y, and negative 9. This becomes one big addition problem where we add our x's, add our y's, add our numbers, right? So 6x plus negative 6x gives me nothing. Cancels. Negative 8y plus negative 9y. Negative 17y. 26 plus negative 9? 17. And then we solve for y. Okay, so therefore my y value is what? Negative 1. Now remember with systems that you are not done until you have all of the variables, right? So I still need to find the x. You can go back to one of the original 2 equations. You can go back to one of our multiplied ones. I stick with the original 2 because it's easier. I go back and plug in y maybe right there.
That's easier.
So that would give me negative 3 plus 2x is equal to 3. Add 3 to both sides. Divide by 2. End up with my x. Typically, we write these as x comma y. Yes? Is substitution or elimination familiar to us?
Yeah, it's
Yes.
easier too, probably.
Yeah, it is easier. Substitution, I will solve. Okay, so what I'm going to do is skip doing this one on substitution. Anyone tell me why I would not want to do that by
We
substitution?
just did it on elimination.
Well, we just did it on elimination.
So what's the point?
It is because it has a lot of fractions. So I'm going to go ahead and show you how to do substitution on example 2. Okay? All right. Couple things on example 2. First off, someone tell me why I think 2 would be a better one for substitution.
Do you have an X?
I have an x that's by itself already. It has no number other than 1. Therefore, it would be very easy to solve for that x and plug it into the other one. Now, that doesn't mean that you have to leave the other equation the same. Why do I say that? Do we like fractions? No. What can I multiply that equation by to get rid of those fractions? 2. So rather than working with that equation, I'm going to work with x plus 5y is equal to 2. Now, here's the issue with solving this one by substitution. What is true about those 2 equations?
They're the same.
They're the same. Anyone remember what that works out to when they're the same equation?
Yes, no real numbers.
Oh, all real numbers.
All real numbers.
That's what I meant.
Why'd you say all
Okay.
real numbers?
Okay, let's see why that works out. Let's say, and let's just do a substitution for the sake of showing substitution. Substitution says, solve for this x. Get it by itself. Subtract the 5y to the other side. Now, x is equal to this. What do I do with that?
What the hell into X?
Plug that into x over in the other equation.
And then you just get all real numbers.
So what I get from this, what happens to my y's?
They cancel.
Okay, so here is where I always say whether I have all real numbers or no solution. You have gotten to the place that a number equals a number. Okay, it's very simple. Is this a true statement? Does 2 equal 2? Yes. That is all real numbers for your answer. If you get 2 equals 0, no solution.
No real
Okay?
numbers.
So if it's a number that's actually equal, all real numbers. If it's a number that is not, no solution. Okay? Zach, the two of you are problems today. No, they probably should not. Maybe I'll move one of you.
Can you move me over there so it'll be far away?
Please. If you put your phone right here.
Okay.
All right. Does anyone need to see substitution before we move on to systems of three?
No, like that.
All right. Systems of three. Grab your calculators.
Oh, yes.
Everyone needs a calculator. I'm going to pull up both of mine on here because I'm going to have to end up showing both.
Are we going to have to do 3 with no calculator?
Nope.
Why back?
You will only have to do 3.
Hey, Jackson. Yeah, I got you.
We're only going to do 3 with a calculator. I got to pull up both of mine. All right. So what we're going to use to do systems of 3 is matrices.
It's this thing.
Okay, so before we type anything into the calculator, we need to be able to organize our systems in a matrix. Okay, does anyone remember doing matrices ever?
Yes.
You did them at one point. I know if you were in pre-AP with me last year, we did them. I don't know if everyone did them all the time, but we'll see. I'm still pulling my calculators up, but the good news is that this is basically where we're ending for today. So, before I pull up my calculators, you need to think about, first off, your systems need to be all lined up. So notice that each of these are X, Y, Z, answer on the other side. Okay? If they are not lined up for any reason, you need to make sure that they are lined up. And I've put all 3 of them kind of stacked there so that we can see what I'm talking about. X, Y, Z, number. All of these. Okay? So what we're going to do is make a matrix out of these. A matrix only includes the numbers. It does not include the X's, Y's, and Z's. So what this translates to in a matrix is this. I'm just pulling the numbers from each of these. Okay? So all I've done is put the X's all in the first column, the Y's all in the second column, the Z's all in the third, and the answers all in the fourth. Yes? Now, because this is all on your calculator, okay, systems of 2, I'm going to ask to see the work, elimination or substitution. Systems of 3, you may use your calculator, okay? But that right there in the purple, I want to see that, okay? Why? Because of anything, it tells me where you went wrong. If a variable's missing and you didn't put in a 0 for it, if you put something in the wrong column, if you didn't move the X to the right side of the equation, if you just randomly put a different number where it shouldn't have been, that's where it tells me if you went wrong. Okay?
What? It just says this.
I know. Because
We
it's,
have to do a second one.
you can, there's a different way that I'm showing you this year. I will show you in just a second. Okay? All right. I'm going to start with the Inspire. Okay? We all have this? If you were in my class last year, we did this with 2 matrices, taking 1 to the -1 power. There's a shorter way that will help us next chapter. So I'm going to show you that now. Okay? So what we are going to do first is find where you get your matrices. If I can, I'm dragging so many windows around here.
Click that button like,
Yep, the next to the number 9 button.
Yeah.
Okay, so if you're on an Inspire, we are going to, in your normal calculation screen, go to the button next to the number 9. This one right here has all of the different templates. This one right here is going to be your matrix one. Okay, there are actually 4 matrix buttons. These are specific size ones: 2x2, 2x1, or 1x2, 2x1. This is pick whatever you want. How many rows did I? All right, so once you've got it reduced in either calculator, you are writing your answer still as an ordered pair. but order triple in this case. So 1, comma, -2, comma, 3. All right?
Nice.
Yes, no, maybe? Good? All right. Okay, we are skipping example 4 and just looking at 1 or 2 word problems involving this. Systems, because of course word problems, yes. All right, so if you would take a look at example 5 with me. We will determine after we write out our equations whether we should have a calculator to solve this or not. If it's a system of 2, we will solve it by hand. If it's a system of 3, we will solve it by calculator. All right, now, this should remind us of some of the word problems in which chapter? All of them, right? We've done a whole lot of this investment business already, but some of these equations come back to us, okay? We have $200,000 invested for retirement, part at 9% and part at 8%. If the total yearly income from the investments is $17,200, how much is invested at each rate? You can solve this without a system if you want to, but some of you that didn't like the whole we've invested X at this amount and 200,000 minus X at this other one will like this way of solving better. Okay, so the question tells us how to set this up. How much is invested at each rate? We are in systems. Okay, so we're going to have an X and a Y. We want to know how much is invested at each rate. So that tells me to set up X as amount invested at what percent? 9%. Y would then be the amount invested at 8%. Now, in a system, if I have an X and a Y, how many equations should I have? 2, right? So I've got 2 equations to make from this. First, what do I know about the 2 amounts that I'm investing in the 2 different accounts? They add up to how much total? 200,000 total. So my first equation is very simple. X plus Y is equal to $200,000 because I've invested some in one, some in the other, but they add up to 200,000 total. The second one should probably include what?
9x plus...
Okay, and we're not going to use 9 because we don't do 9% that way, but yep. So we do 0.09x plus point what? 0.08y is equal to, how much do we get from that total? 17,200. All right. I have not done a great one where I did substitution. So let's go substitution here. What variable should I solve for? X or Y in the first one. Doesn't really matter. Okay? So let's solve for this Y. If I get that Y by itself, it's going to be equal to 200,000 what? Minus X. What do I do with that Y now in substitution? Take this and plug it in for Y where? In my second equation. So my second equation is now going to say 0.09x plus 0.08. In place of Y, I'm going to put 200,000 minus X. This is equal to 17,200. This should look like our equations from the first chapter. That's how we kind of came up with those. Now, how do I solve this? Distribute, right? So I've got 0.08 times 200,000, 16,000. 0.09x plus 16,000 minus 0.08x equals 17,200. Whoops, that's one too many zeros. Combine your x's and move your 16,000 to the right. Gives me 0.01x is equal to 17,200 minus 16,000 is 1,200. What's my last step? Divide by 0.01. So X is 120,000. That's the amount invested at 9%. Y, how do I find Y? Plug in X way back up there where I have it as 200,000 minus X. That's the easiest place. Or it is just what adds together with 120,000 to give me 200,000. And Y is invested, or 80,000 is invested at 8%. Okay. So for some of you that struggled with those equation setups in chapter 1, this gives you another way to set it up. It works out the same. You can do it as a system. Sometimes it makes more sense that way. Okay. One more of these and I'll be done. Give you homework time. Okay? In example 6, 2 species of deer, A and B, live in a wildlife refuge. They're given extra food in the winter. Each week they receive 2 tons of food pellets and 4.75 tons of hay. Each deer of species A requires 4 pounds of the pellets and 5 pounds of the hay. Each deer of species B requires 2 pounds of pellets and 7 pounds of hay. How many of each species of deer will the food support so that all the food is consumed each week? When I set up word problems with these, the first thing I do is set up what's my X, what's my Y. And that's always based off the question. So in this particular case, this question is asking me to find what as my X and my Y. How many of the species of deer? Okay, so I'm going to make X type A deer. Or you could just use A and B. That's also fine. Y is going to be the number of type B deer. Okay. Now I have to set up 2 equations from this. The way they've actually put the information in the sentence is a little bit confusing. Because they want you to go after like 8x and 5y and then 2x and 7y, because those are the same sentences, right? But what is y and x actually? The number of deer. So what I'm going to tell you instead is let's make one equation about all the food pellet information and one equation all about the hay. All right, so all the food pellet information, this, and this. That's all going to give me one equation. Think about it for a minute. What is going to be multiplied by x? Which of those numbers? 4. Each deer of species A requires 4. So 4x. What's going to be with y? 2. Each species B requires 2 pounds. And they receive how much total? 2 tons. Uh-oh. The 4 and the 2 are in terms of pounds, and that is in terms of tons. Not something I would ever make you memorize, also, FYI. Okay? Pounds in tons.
2,000?
I don't even remember.
So it means 4,000.
2,000? All right. Oh, look at you guys. You know more than me on that. Okay, I have no idea. All
If we
right.
get one of those,
So really, I will give you the information if you need that. That is not something I expect you to know how many pounds are in a ton.
Yes.
Come on now. Google is our answer to that.
I was gonna say. So
Okay.
Google first?
I will give you the
I was
information.
gonna say if we need to know that, I might actually have to study for this.
I know. Me too. All right. So that is then 4,000 because 2 tons at 2,000 pounds each is 4,000. Okay. Now, second equation is all about the hay. So using that same kind of setup, what do I have? 5x plus 7y. Now, this is going to take a minute. 4.75 at 2,000 pounds. 7,500, you said? Okay. That is 9,500. Take a minute on your own papers. How should you solve this?
Elimination.
Elimination. Go for it. Take a minute, solve by elimination on your paper. We're actually going to do two things with example 6 because I'm not going to do the examples on that. You're going to solve this by hand and then use matrices to check your answer. Solve by hand, use matrices to check your answer.
So elimination is where we cancel out either your x's or your y's. So I would look at your x's and say the common multiple is 20. So I would go ahead and multiply this all off. And there's your 20, and I do negative 4, so that they automatically cancel out. So I don't like to subtract. 20x plus 20y equals 20,000. Negative 20x.
Yeah.
Okay, so this is where we did elimination at the beginning. I would multiply here to cancel out either your x's or your y's. So I'm looking here and saying my common multiple for my x's is 20. So what do you multiply this one by? Get 20 multiplied by 20. And I'm looking here to say that I'm not at 20, so I cancel it out. So we're going to multiply this one by 20.
Like if you lose.
All right, guys, there's edits to homework, so listen. Edits to homework. Ready? Are we ready for the homework? We all don't want to do all of it, yes?
No, we don't.
Okay, so the first part is finishing up some of our linear. We said, what did I say on that? 13 through 16 on the linear word problems, back on 2.2. For some reason, when I typed this, it says 3.4 notes instead of homework because I didn't change my title, but just FYI, it is the homework. Nope, lies. We are going to do 1 through 9, but cross off 10, 11, and 12. We will never do 10, 11, and 12. And there's a good reason for that. Okay?
Why not 10?
Wait, where's the homework?
It says notes at the top. It means homework. Yep.
Wait, so we'll never do a question like number 10?
No.
Why?
We will, because it cannot be solved correctly. It can be solved in terms of the other variables, but it cannot be solved on its own for a number. And I don't see a point. All right? So we are basically on the 3.4 homework, crossing off 10, 11, and 12. Just to be clear on my expectations then. A system of 3, such as questions 9 and 8. Those are your calculator questions. Okay? So on 3.4, you need to choose substitution or elimination to solve on 1 through 7. 8 and 9, I just need to see your matrix set up and your answers. We crossed off 10, 11, and 12. And then on the word problems, I believe 14 will end up being a system of 3. So you can solve that with your calculator. The other 2 can be solved by hand. Okay? 14 is a system of 3. So that one you can solve in your calculator with the matrix. Are we ready? Yes? All right. Okay, you need to pack up your stuff. You can work on missing homework. You can work on this homework.
Or philosophy.
You may not be on your phone if you don't have those done. That's the statement I'm going to make. I didn't say you can't study for a test that you have. Yeah.
I wasn't here last
Yeah.
week. I see my test.
Yes. It is in your bin. I think I put it there. All right. Online people, any questions or problems from... Okay, we do have a quiz next class.
You can transform.
I'm not including systems on it, I don't think, unless there's like a massive, everyone wants it on there because it's easy. But I don't know, maybe. So I'll look at the quiz. I'll email out exactly what's going to be on it. Okay? Y'all are welcome to sign up if you have no questions.
Why?
Yes, ma'am.
Because Justin Jefferson is the son.
It shouldn't have